Hello everyone, we're going to look at matrix factorization. This is section 2.5. We're going to recap certain things we have done before. Now we learned previously how to create a new matrix by multiplying two or more matrices. Now here we're going to go the other way around. We have one matrix, we will like to write it as a product of two or more matrices, which is basically called matrix factorization. Factorization of a matrix A is an equation which is expressed as a product of two or more matrices. To do such matrices, we are going to learn about LU factorization. Now this is used a lot in computer science applications. Now for LU factorization, we're going to assume that A is an M cross N matrix which can be reduced to echelon form without row interchanges. As a result, this A can be written as in the form of L times U, where L is a square matrix of size M and it is a lower triangular with ones on the diagonal. This is the matrix we're talking about. And U is an M cross N matrix in the echelon form of A. This is the matrix we're looking at. Now recall from section 2.3 that if you have a square lower triangular matrix, then that matrix is invertible. And hence our L matrix is invertible, and we also call it a unit lower triangular matrix. It's very useful, this LU factorization, because when you write A as a lower triangular times an upper triangular matrix, this equation AX equals B can be written as LU, so AX equals B will be LU X equals B. Now which by our matrix properties we can write as L times UX. Now in order to solve these matrix equation, you can first solve Ly equals B by saying let Ux is By, and then we can get for X. The reason it is very nice to use LU factorization because we are only going to have triangular matrix to solve it. The figure given below will help you that. So suppose we have a matrix A. By multiplication, we get this matrix B. Remember, this is AX equals B. Now, this A can be any matrix, but if you break it down as a product of two triangular matrices, it makes life simpler. Because remember what we just said, A is L times U. So L times U X equals B. Now, if you're going to take Ux as Y. So in order to solve this one, first thing we're going to do is you multiply Y with L on the left-hand side and you get another matrix B. And on this matrix, then you're going to say, then you go ahead and say Ux equals. So you're going to go ahead and solve this one. So multiplication by U gives us X. Okay, now let's start with an example. Now, we want to solve AX equals B by using this LU factorization. The L and U will be given to us. This is a matrix. 1 minus 1, 2, 1 minus 3, 1, 3, 7, 5. It's a 3 by 3 matrix. This is this A for us. This is X and this is B. Now L and U are given. This is clearly a lower triangular matrix and this is an upper triangular matrix in the echelon form. The first thing we're going to solve is, remember, Ly equals B because we're looking for X. X is related to your U. So, but we're going to first look at L times V. So we solve Ly equals B. Remember, we're going to create the augment matrix. And when we solve the augment matrix applying these elementary row operations, we are able to solve, the first thing we're going to make is we're going to make these two elements in the first column 0, and we get this matrix, and then we will apply from here. We are going to go ahead and make this element -5 to be 0 by applying this row operation, and we get a triangular matrix. So when we, an identity matrix, and it's a triangular matrix too. This is the value for y. So basically, remember, you're solving this linear system where we're basically looking for y. So once we apply this algorithm, we get this element. Now we want to solve for x, because that the original problem was ax. Keep in mind, original problem is ax equals b, or we have that lux equals b, or L times y equals b. We have to solve for x. That is the most important thing. But in order to get to that point, first we're going to do ly equals b, which we just did. We got y. Now we're going to substitute this y here. We're going to now go ahead and solve for our ux. So now solve ux equals y. So u already is given to us. X is the one we're looking for. So we're going to write the augment matrix. This is u for us. And this is y. The last column of the augment matrix is given by the constant terms. Then we apply these algorithms. First of all, we are going to make this a 1 by dividing multiplying this row 3. This should be row 3, guys. Row 3 by -1, 6, and you get this new equivalent matrix. After that, we are now going to go here. Here we are going to now make these two elements. The third column, the first two terms, 0, by applying r1 minus 2, r3 goes to r1, r2 plus r3 goes to r2, and we get this new equivalent matrix. Now then we're going to make this term 0. We do r1 minus 0.5, r2 goes to r1. And remember, we're looking for a solution. Just now we have to just make this to be 1. And then we multiply the second row by minus 0.5, and we get this new matrix 1 minus the identity matrix and the values for x, which is -5, 1, and 3. And hence we have got the solution for our matrix. I would like you guys to practice these following questions from the book. These are 7 to 12, and these are the ones which you will do after I have done how to do LU factorization on a given matrix. That is what I'm going to be doing in the next part of this video. Thank you.